In this video, we're going to talk about solving inequalities. If you don't remember what inequalities look like, they look like this. Sometimes we refer to them as alligator mouths. So this one that opens to the left is greater than. And the one that opens to the right is less than. Now remember, sometimes things aren't just greater than or less than, sometimes they're equal to. So when we draw a bar under it, it means the same thing it was, so greater than, but it or also could be equal to. And that same thing happens for less than or equal to. So without the bar, it just means greater than or less than. With the bar means it could be equal to as well. So how can we denote this? Well, one way to denote it is using variables and our inequalities. So this says x is greater than 5. We could also say x is greater than or equal to 5. Okay, so that's one way. We can draw this on a number line. And to do the lazy way, I'm just going to put 5 on there. Okay, now when you're putting 5 on there when it's just greater than or less than without the bar under it, you get an open circle. When you do have the bar under it, you get a closed circle. And here's a little trick. As long as the variable is first, the arrow will point the same way as the inequality. So this will point there. But if you can't remember that, if you think about it, x is greater than 5, so where are the numbers that are greater than 5? Well, over here would be 4, 3, 2, 1. Are those numbers bigger than 5? No. Over here would be 6, 7, 8, etc. Are those numbers bigger than 5? Yes. So up here, positive infinity is where it goes to. That's an infinity sign, by the way. It looks like a lazy number 8. Okay, and this is a number line, like we said. But we also have something called interval notation. So you need to pay attention to how you're asked to list it. If you're asked to list it as an inequality, it'll look like this. If you're asked to give it on a number line, it will look like that. If you're asked to do interval notation, this is what it looks like. So you move from left to right just like you read. First thing I encounter on my graph is a 5. And then the last thing I encounter on my graph is an arrow, which is pointing to positive infinity, just like we talked about over there. So 5 is where my graph starts, and where does my graph end? At infinity. So interval notation, you tell me the beginning and the end. Since this has an arrow, it doesn't end, so it goes to infinity. Now, then when I do interval notation, so this one also goes from 5 to infinity. When I do interval notation, if I'm not equal to the number, I get parentheses. So is there any way to ever be equal to infinity? No, that number is way too big. So infinities always get parentheses. Oops, sorry. This 5, is it an equal to? No, it's just greater than, so it also gets parentheses. But over here, this 5 being closed and being or equal to, this gets a bracket to show that it's or equal to. Okay, so if you ever have to do interval notation, we can review that again later. That was just really quick. Our next example asks us to write an inequality to represent a couple things. So A, wind speed, W, is at least 40 miles per hour and less than 74 miles per hour in tropical storms. Okay, so you have to always pay attention to what letter it gives you. Since this gives us W, I know my variable is going to be W. So W is wind speed. And I've got a couple things going on here. First, I see that I have at least 40 miles per hour. So that is going to be W, and then at least means it's more than, but could it be equal to, so it could be 40 or more, so greater than or equal to 40. But then I have this word, and. And means I'm going to have a compound inequality with and. There are two types of compound inequalities. There's and there's or, and we'll get to or in a moment. But the and ones all go in the same string of an inequality. So you have something that's smaller, your variable in the middle usually, and then something that's larger. Okay? So this is how you write and. So let's get we know that W is going to be greater than or equal to 40, and we've got something else. It also has to be less than 74. So can it be 74 exactly? No, it can only be less than. So this one does not get an or equal to. Okay, so now that we have that set up, we are going to rewrite it as our compound inequality. Okay, so when we wrote this as an and, where was the W? It was in the middle. Okay, and the smaller number was over here, 40, and the larger number was over here, 74. Okay, now this one is already set up with W on the left and the number on the right, so I can just bring down that sign. But this one over here, W and 40 switch places. Do you see how that happened? So see how my alligator mouth is eating the 40 because is eating the W because the W is larger? What do you think is going to happen here? Well, instead of using this inequality, what are we going to have to do to it? The W is larger, so it's going to have to go this way. It is reversed. Okay, so it's reversed from what it was because it still needs to be eating that thing. So let's talk about that. You will reverse the inequality if you have to switch sides or if you have to multiply or divide both sides by a negative number. That's not hashtag, that's number. So if you have to multiply or divide by a negative number, you will switch your inequality. It'll trade from being this way to being the other way, from being a greater than to being less than, or vice versa. Okay, B on this same example, 5 less than a number X is greater than 47. Okay, 5 less than a number is greater than 47. So let's start this out. Okay, what does 5 less than a number mean? Well, it means I'm going to take my number X and I'm going to subtract 5 from it. So I'm going to take my X and subtract 5. And then it says that is greater than 47. So this means greater than 47. Okay, I'm going to take 5 away from our number x, and then it is greater than 47. So now, do you think we get to just leave this and it just chills? No. Now we get to solve. So to solve this, we do the opposite of what it says right there. So we add 5. So x is greater than 52. And now we can graph this. So let's draw a fabulous number line. Put 52 on there. Does 52 get an open circle or a closed circle? Without the or equal to, it gets an open circle. And then where are the numbers that are greater than 52? Are they on the left or the right? They are on the right. And just for giggles, let's do this in interval notation. So moving from the left to the right, I begin at 52. So in interval notation, I would start at 52. And then I would go to an arrow. That means infinity. And since this is in a positive direction, it means positive infinity. Infinity always gets a parentheses, and this 52, since it's not filled in, since it's not or equal to, that also gets a parentheses. Woo, throwing markers around. Okay. Let's learn more things. Okay. Let's solve and graph some stuff. So first example, -7 times k is less than 63. So what would I need to do to solve this? Well, I would need to divide both sides by -7 because k is being multiplied by -7. So here, k is now the only thing because the 7's would cancel. 63 divided by -7 is -9. Now this currently says less than, but I divided by a negative. So that's one time that I need to reverse my signs. Or reverse the inequality, sorry, not signs. I apologize. Making all sorts of mistakes. Okay, so drawing my number line, put a -9 on there. This being greater than, not equal to, it's going to have an open circle, and greater than, it's going to point to the right, to infinity. Man, we've had a lot of greater thans. Hopefully this next one is less than. Okay, next one, I've got 4 times x plus 3 plus 6 is less than or equal to 50. Okay, so the first thing I'm going to do is distribute this 4 so I can combine like terms. So I've got 4x plus 12 plus 6 is less than or equal to 50. Here are my like terms, 12 and 6. So since they are on the same side, all I do is add them together since they're on the same side of the inequality. So 12 plus 6 gives me 18. Okay, now that all my like terms are combined, I can move stuff from one side to the other. So I'm going to subtract 18 from both sides. So that leaves me with 4x is less than or equal to 32. And we still need to get the x by itself, so we divide by 4. So x is less than or equal to 32 divided by 4 is 8. Okay, so let's draw this one over here just to conserve some space. So here's my 8. This one is finally going to be closed because it's or equal to. Ooh. And finally we have a less than. So this is less than. Where are the numbers that are less than 8? They are on the left side. Okay, next. If it costs $220 plus $7 per student to take a field trip. This is why I don't pay for field trips. And we have a budget of $500. how many students can go. Okay, here's where we're going to talk about the Algebra 2 rules for word problems. So the first of the Algebra 2 rules for word problems is to define your variable. Okay, this is generally not too bad because it's usually whatever the question is. So if we look here, the question says, how many students can go? Okay, well, so my variable x is going to be the number of students that can go on the field trip. That wasn't too bad. 2 is going to be that we need to write our inequality or equation, whatever we're dealing with, in this case an inequality. Okay, so what do we got going on? So it looks like we have $220 no matter how many students. So I'm definitely going to have to pay $220 no matter what. Then it says plus $7 per student. So I know I'm going to have a plus. And then it's $7 per student. That word per means multiplication. So 7 times my number of students. And then that's all money and money, so they can go in the same inequality. And we have a budget of $500. So $500 is going to go over here. Okay, so where did we get this? Well, the $220 is a fixed cost, how much we have to pay no matter what. The $7 is going to be times the number of kids that get to go. And then the 500 is our budget, right? Okay, so when you have a budget, do you get to spend more than your budget? Do you ever get to spend more than your budget? No. You have to spend less than your budget, correct? Can you spend right up to your budget though? Yes, so it could be equal to. So this means we can spend no more than our $500. So if anything ever says no more than, it's going to be less than or equal to. Okay, step 3 is we solve, and then I'm going to go ahead and put step 4. We state our answer in a complete sentence. Okay, so here, to figure out what we would need to do, first we need to, it looks like, subtract $220. So that will cancel. And then I will have 7x is less than or equal to 500 minus 220. That's going to be 280. And then we will divide by 7. So x is less than or equal to 28 divided by 7 is 40. So my sentence is we can take 40. Can we take exactly 40? Yes. This says x is less than or equal to 40. So we could take 40 or less. So we can take 40 or fewer students. Okay. Now let's get into always, sometimes, or never true. Come here, marker. Okay. Always, sometimes, or never true. Okay, so my first example here is going to be 3x plus 2 is less than or equal to 7. Let's see if this is sometimes, always, or never true. So first, you know, we would subtract 2, and then I would have 3x is less than or equal to 5. And then I would divide both sides by 3. So x is going to be less than or equal to 5/3. Okay, so remember, x stands for any number ever. Are there any numbers ever that can be less than 5/3? Yes. Are all numbers less than 5/3? No. So my answer here is sometimes. How about this guy? 6x minus 13 is less than 6 times the quantity x minus 2. First thing I'm going to have to do is distribute. So I have 6x minus 13 is less than 6x minus 12. The first thing you want to move is always the x's. So I'm going to subtract 6x from both sides. Always, always, always on these especially, move your x's first. Okay, now notice what happened. My x's all disappeared and all I'm left with is numbers. So this says 13 is less than negative 12. So let's graph these on a number line real quick. Negative 13 is here, negative 12 is here. So is 13 less than, negative 13, sorry, less than negative 12? Yes. Is it always going to be less than negative 12, or sometimes, or never? Well, always, because it's always to the left of negative 12. Last one of these, negative 7 times 3x minus 7, quantity, that quantity, plus 21x is greater than or equal to 100. I barely fit it on there. Can you see that? There we go. Okay, and again, first thing, distribute. Let's write that a little smaller so I can fit it. Negative 21x plus 49 plus 21x is greater than or equal to 100. Now I combine like terms. 21x and 21, those are my, negative 21x and 21, those are my like terms. So those cancel. So I'm left with 49 is greater than or equal to 100. Well, let's think about this in money. If I have $49, is that more than having $100? No. Is that ever going to be true? No, never. Okay, just a little bit more. Almost done. Thanks for your patience. Okay, last page, I promise. All right, what we haven't talked about yet much are compound inequalities. We talked about compound inequalities with and, but we haven't talked about our compound inequalities with or. So when we have a compound inequality with or, you need to put both solutions on the same number line. Okay, so let's do a couple examples. 4x is less than 16 or 12x is greater than 144. Okay, to solve these, on this one I would need to divide both sides by 4. On this one I would need to divide both sides by 12. So on this one, the 4's cancel and I get x is less than 4. Or, on this side the 12's cancel, x is greater than 144 divided by 12 is 12. Okay, so let's graph these. So I have 4 and 12. If all I do is put 2 marks here, which one is the smaller number? 4 and 12 is the larger number. Okay. So x is less than 4, so that gets an open circle because it doesn't have an or equal to. And where are the numbers that are less than 4? They are to the left. So that's what that one looks like. Or x is greater than 12. So this one again, open circle because it doesn't have an or equal to. And the numbers that are greater than 12 are to the right. So that's what that one looks like. Let's see if I can squish this one in here. Okay. 3x is greater than or equal to 3, or 9x is less than 54. So to solve these, we are still dividing by 3 on that one, and dividing by 9 on that one. So this one I have x is greater than or equal to 1, and on this one I have x is less than 6. Something interesting has happened. You will see what it is. Okay, so on here, my smaller number is 1, my larger number is 6. Now on the 1, I get a closed circle. On the 6, I get an open circle. But watch what happens. X is greater than 1, so where are the numbers that are bigger than 1? They're over here on the right. Correct? Where are the numbers that are less than 6? They're over here on the left. So what has happened? I have an arrow on the left and an arrow on the right. So that means when we have or, and this happens, it means our answer is all real numbers. Because all numbers are either greater than or equal to 1 or less than 6. All numbers are included in that. Okay, last one. Okay, in order for the curling team to qualify for state, they must average at least 283 points per game. And I left in a line there on purpose. At their last 3 games, they scored 300, 270, and 180 points. How many points must they score at their last game, and they only have one more, in order to qualify for state? Okay, so going back to our Algebra 2 rules of word problems, first thing we need to do is define our variable. And we find that in our question. So looking for our question, it says, how many points? So X is going to be the number of points. Oh, but 300, 270, and 180 are also points. I guess we probably need to be a little more specific. So how many points win at their last game? So number of points in their last game. Okay, so define the variable. Step 2, write our inequality. Okay, well this is going to be a little tougher. So we know that they have 300, 270, and 180 points in their games, and then they have X in their last game. And it looks like we need to find the average of those things. And remember, to find the average, you find the sum of the numbers and then divide them by the number of numbers, or the number of values you have. Okay, that's how you find average. Add them all up, divide by how many there are. Okay, so it looks like I'm going to have 300 plus 270 plus 180 plus X, and I'm going to divide that by how many there are. So how many games? 4. Okay, so I've got that side set up, but it's not an equal sign, it's an inequality. This says at least 283 points. So the average of my scores has to be at least 283 points. So it doesn't need to be exactly 283 points. Well, it could be, but at least means it needs to be bigger than that, right? So it's going to be greater than or exactly 283 points. So down here, greater than or equal to 283 points. So anytime you see at least, it means greater than or equal to. Okay, so let's do this problem. So if we add all those up in our handy dandy calculator and or brain, we get 750 plus x divided by 4 is greater than or equal to 283. You always combine like terms first. So now that I've combined my like terms, I now need to solve this inequality by getting rid of stuff. I cannot subtract the 750 because it is being divided by 4. So the first thing I need to do is multiply both sides by 4. Now I multiplied both this side by 4 just to cancel that denominator, so it goes away. So I do not multiply this numerator by 4. All that happens is that it made the 4 in the denominator go away. But on this side, I don't have a denominator to cancel, so I do multiply. So 283 times 4 is 1,132. And then I continue to solve this. So I subtract 750. And I determine that x is greater than or equal to 382. So I have solved, but remember step 4 says I have to write this in a complete sentence. So in a complete sentence, they must score 382 or more or less or more points. A better way would have been to say at least 382 points, probably. That's all for this one. Good luck on your assignment. Let us know if you need help.